So today I'll be doing the final test on the 200 amps lithium battery from Lemax. I've allowed these batteries to charge for the past 3 days without using them. So today I'll be doing the final test with these two batteries. But I observed that my two batteries charge differently because I connected them in series. And due to lack of equalizer, they actually charge differently. Now this first one is giving about 13.4 volts, while this guy is maintaining 14.0 volts. So you can see there is much difference in the battery due to lack of equalizer. But nevertheless, I'll still put on the inverter to carry out our test. So I'll put on the inverter now, then we'll put on some appliances to see how much energy will be draining from these very batteries and to see how many hours it will take us to drain out these batteries. We started this test at about 11:03, that's AM. So I'll put on the inverter now, then we'll check the amount of load we'll be draining from this inverter. We have about 5 bulbs on here. Each of these bulbs is 100 watts. So in total we have about 500 watts. And I'll put on this AC so that our load will be around 1200 or 1300 watts. This laptop also is charging from the inverter, and this fan as well is working from that very inverter. So I'll use my digital multimeter or use my clamp meter to see the amount of energy we are draining, and also to see the number of hours it will take us to drain out these batteries. We are draining about 5.1 amps. So I'll multiply it by 220 to see how much energy we are draining out. 5.1 by 220. So we are consuming around 1122 watts. With this amount of load at 80% DOD, if this other battery that is on 13.4 doesn't go off, these batteries are expected to give us about 3 hour 6 minutes or 3 hour 16 minutes. So we started the test at about 11:03 and this is 11:19. So it's been 3 hours 5 minutes since we started this test. And if you can see, I added another bulb to make it 6. So here we have 600 watts. We've maintained this load for the past 3 hours 5 minutes. Our AC is still on. The fan also is still running, and our laptop is still on the inverter. So we've maintained this load on that two batteries, 2.5 kilowatt hour each from Lemax, for the past 3 hours 5 minutes. So let's check out the battery, how much voltage we have left in the battery. The battery have 80% depth of discharge, so it's expected that the battery should give us 3 hour 30 minutes or 3 hour 20 minutes. So it's already 3 hour 5 minutes or 3 hour 6 minutes. We've maintained the same load and the inverter is still running. So let's check out the voltage that is left on each battery. I'll still check out the current to see if we have actually maintained that 5 amps which we were draining earlier. You can see we've maintained the same 5.1 amps from around 11:03 down to 2:08 or 2:09, and the inverter have been running. On the inverter screen we have 33% load, and it's fluctuating between 1100 watts and 1200 watts, which is 1.1 kilowatts or 1.2 kilowatts. Let's check the voltage on each battery so that we can predict how much energy we have left on this battery. This battery is still maintaining 12.5 volts. This guy also might be maintaining the same voltage, 12.6 volts. From our load test, these batteries have actually proven that they can give us up to 80% depth of discharge or even more. It depends on what percentage or what depth of discharge you set your battery to. For those of you that are looking forward to do a 1 kVA system, you can go for this battery. This is a 200 amps lithium battery from Lemax, and the batteries accept series, because if you can see, this is a 24 volt inverter from Luxon, 3.2 kilowatts or 3.2 kVA connected to these two batteries. This inverter presently is working from these two batteries, and these two batteries are connected in series. So 200 amps plus 200 amps give us a total of 400 amps if connected in parallel. But connected in series, we have higher voltage with the same 200 amps, but in total we have 5 kilowatt hour, and the battery have been able to deliver up to what is stated on the manual, which is 80% depth of discharge. From our load test, the Lemax 200 amps lithium battery have proven that it's very reliable. And for those of you that have been asking how much does it cost, the 200 battery costs 570,000. If you're interested, you can come to our office at Shop 7, Deluxe Plaza, Lugbe, Abuja, Nigeria, to get the battery. The battery comes with 5 years warranty, and also their service center is available here in Abuja. If you have a problem with your product, it can be replaced or fixed within the warranty period. The system is still on with the same amount of load, which we are draining about 5.1 amps from the inverter, a total of 1200 watts, and the batteries were able to endure for about 3 hours plus. So on the norm, the battery is 80% DOD, which is expected to deliver 3 hours 30 minutes, but I'm 100% sure that the battery will deliver more than that. So the battery have proven that it can go beyond that. But if you want your battery to go up to 8 years or 10 years, as written on the battery or the battery manual, you have to maintain the 80% DOD. You can actually go up to 90% DOD, but the best way to enjoy the battery is to go 80% DOD.